Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to troubleshoot one ticket, and ticket is, as you can see in front of you, ticket is this. You need to troubleshoot OSPF over DMVPN so that branch offices can communicate with each other. Guys, this is my topology. In my topology you can see router 1 is hub router, router 2 is spoke 1, and router 3 is spoke 2. That means this is my headquarter, this is my branch office, this is my branch office, and this is also my branch office, right? This is, let's say, branch 1, and this is branch 2, and this is headquarter. First of all, I am going to verify the connectivity. That first of all I will check that really the headquarters user are not able to communicate with branch offices, or user to the branch offices, or branch offices are not able to communicate with other branch office. Okay, so let me take access of this PC. Okay, before verifying the problem, let me make you understand the IP configuration in this scenario. Here I have one ISP. You can see through ISP I have connected all the branch, headquarter and branch 1, branch 2, all the branches are connected through ISP. And between router 1 and ISP I am using this network 11.1.1.0/24 maybe. Between router 2 and ISP I am using 22.1.1.0 network. Between router 3 and ISP I am using 33.1.1.0. Okay, here in my LAN network I am running, here the LAN which is connected to headquarter, I am running the network 19 I am running network 10.1.1.0/24. In the branch 1 I am running a network 20.1.1.0/24, and in branch 3 and branch 2 I am running network 30.1.1.0/24. Okay. Uh, and on the tunnel here you can see on the overlay network means, this is the underlay network. These are the public IP address, right? These are the public network, and the tunnel is the private network, right? Over the public I have created the virtual private network, and on the virtual private network I am running IP from 192.168.10.0/24 network. So this is my overlay network, and this is underlay network. Done. First of all, I am going to take access of PC, and let me verify the connectivity to their default gateway. From PC number 1 I am going to ping to the gateway. Let me check the IP address of PC1 first. Say run so, and IP address is, you can see, 10.1.1.2/24, and gateway IP address is 10.1.1.1. That means 1.10.1.1.1 is running on router, and this is the IP address 10.1.1.2 is the IP address of my PC. Let me ping my gateway 10.1.1.1. From here you can see I am able to ping my gateway. That means PC1 is able to ping their gateway. Okay, then guys, let me check the IP address of PC2 here. PC2, and what is the IP address of PC2? Let me run so command here. IP address of PC2 is 20.1.1.2, and gateway IP address is 20.1.1.1. Let me ping the gateway 20.1.1.1, and you can see I am able to ping the gateway IP address, right? In the same way I am going to verify IP of PC3 as well, and from PC3 also I am going to ping the gateway. So IP address of PC3 is 30.1.1.2, and gateway IP address is 30.1.1.1. Ping 30.1.1.1. So you can see all PCs are able to ping their default gateway. Now from PC number 1 I am going to ping PC number 2. Okay, so let me take you to PC1, and here I am going to ping, let's say, 20.1.1.1. So as you can see, really I am not able to ping 20.1.1.2, 1.1.2 also, 20.1.1.2 also, you can see I am not able to ping, right? That means yes, headquarters are not able to communicate with branch 1. Let me verify the connectivity between headquarter and branch 2. Ping, let me ping PC3. IP address of PC3 is 30.1.1.2. You can see I am not able to ping PC3 also from PC1. Okay, so yes, we have some problem. Now I am going to verify the configuration first on all routers, right? Here This is my hub and spoke topology, I think. Let me verify on router number 1. On router number 1, okay, we have some log message as well of EAGRP. You can see the EAGRP neighborship is reset, right? The process or the adjacency forced to reset. Okay, and all I think I have engineer have run in debugging command on router number 1. Okay, now so run interface tunnel 1. I am going to verify the tunnel 1 configuration, and before verifying the tunnel 1 configuration, let me ping the ISP. From router number 1, I should be able to ping ISP. So ping 11.1.1.2. 11.1.1.1 is the IP address of my interface, and 11.1.1.2 is the IP address of ISP. If you want to verify, I can show you the ISP configuration. Let me take access of ISP router as well, and on ISP router I can run commands. So IP interface brief exclude unassign. So you can see on serial 2/0 IP address is 11.1.1.2. On serial 2/1, which is connected to router 2, IP address is 22.1.1.2, and on serial 2/2, which is connected to router 3, IP address is 33.1.1.2. Means on ISP side I have configured IP address .2, and on router I have configured .1. So let me close this terminal and let me take you again to router number 1, and I am going to ping 11.1.1.2 from this router. So you can see I am able to ping the ISP IP address, public IP address. That means there is no any problem between router 1 and ISP. From router 2 also, let me ping the ISP, ping 22.1.1.2, and you can see I am able to ping the ISP. Means here also I don't have any problem. Let me ping from router number 3, ping and 33.1.1.2. I am able to ping ISP from all the branch routers, right? Means there is connectivity between your router and your edge router and ISP. Now I am going to verify the configuration of tunnel interface on router number 1. So run interface tunnel 1. I can run this command. So run interface tunnel 1. So run interface tunnel 1. Okay, by running this command, you can see, let me copy the configuration here. Where is the configuration, guys? Here is the configuration, interface tunnel 1, and these are the configuration. Let me paste it because here I have some log message. Because of that, maybe you are not able to see the configuration. So I am going to paste the configuration here. This is configuration of router number 1 tunnel interface. I am going to copy the configuration of tunnel 1 of router 2. So let me take you to router 2, and here I am going to run interface tunnel 1. This is the configuration. Let me copy this configuration here and let me paste it in the notepad. So this is configuration on R2. Let me write here. This is the configuration of R1. This is configuration of R2, and on tunnel interface. And let me copy configuration of R3 also. R3, and where is R3? Let me copy the running configuration of tunnel interface. So run interface tunnel 1. So this is configuration on R3. Let me copy this and let me paste it over here. Okay. Okay, let me maximize it so that you can see the entire configuration. On router number 1, we have, on tunnel 1, IP address is 192.168.10.1. subnet mask is this one. Okay, IP address on tunnel 1 interface of router 2 is 192.168.10.2. IP address of tunnel 1 on router number 3 is 192.168.10.3. Now I am going to verify the connectivity between tunnel to tunnel. From router number 1, let me ping the tunnel IP address of router 2. Ping 192.168.10.2. I am able to ping the tunnel interface IP address, right? Destination tunnel. I am able to ping tunnel of router 2 from router 1. Let me ping tunnel of router 3 also, and you can see I am able to ping tunnel 1 of router 3 also. That means tunnels interface are able to communicate with each other. Okay, again I am going to show you the configuration. Okay, apart from this, this is the IP configuration on tunnel interface. I have enabled the NHRP. So NHRP network ID 1, tunnel source is serial 2/0. Let me verify. Yes, tunnel source is serial 2/0. It is fine. And then tunnel mode GRE multi-point. So on this router, on R1, we have configured tunnel mode multi-point. Here we have multi-point configuration on tunnel interface, and on other router, on router number 2, tunnel IP address is this one. IP NHRP map 192.168.10. This is the destination tunnel IP address, and this is the destination NBMA address. Okay, so done. This configuration is perfect, guys. And here I have defined the tunnel destination as well. You can see that means this side on router number 2 we have configured which type of tunnel. We have configured GRE tunnel. Means point to point tunnel, and on R1 we have configured multi-point tunnel. Here also we have GRE tunnel. Okay, till now we have verified this. Okay, after that on router number 2 you can see this is the command to enable NHRP. This is the command for the mapping, right, of destination tunnel and destination NBMA address. And then we have NHS IP NHRP NHS 192.168.10.1 means hub router. Tunnel source is serial 2/0 and tunnel destination is 11.1.1.1. This is the NBMA address of router 1. This is the NBMA address of destination tunnel. In the same way on router number 3 also you can see configuration of tunnel is perfect. IP address is this one. IP NHRP map is also fine, 192.168.10.1, and NBMA address is 11.1.1.1. Then IP NHRP network ID is 1. IP NHRP NHS 192.168.10.1 perfect. Tunnel source is serial 2/0 and tunnel destination is 11.1.1.1. So on router number 2, router number 3 and router number 1, tunnel configuration is perfect. We don't have any problem here. Okay, now and all tunnels interface are able to ping each other as well. Okay, so now I am going to verify the OSPF configuration on these routers. So first of all, let me take you to router number 1, guys. On router number 1, let me check OSPF neighborship. So IP OSPF neighbor. So you can see neighborship is stuck in init state with 2.2.2. Okay, let me check the OSPF configuration, how many command I have run. So run and section OSPF. Let me copy the OSPF configuration from here. Router OSPF 1, router ID 1.1.1, and I have advertised this network. Okay, I have not advertised LAN network. So first of all we will form OSPF neighborship. I'm going to remove it. This is the OSPF configuration on router number 1, guys. R1 OSPF configuration. Let me show you the R2 OSPF configuration. R2 OSPF configuration. Where is R2? Here it is. So run section OSPF. Let me copy this and let me paste it over here on R2, and then R3 configuration. Let me show you the R3 configuration as well. So where is R3? Here it is. So run a section OSPF. This is OSPF configuration on router number 3. So you can see OSPF configuration is also fine on all routers. We have advertised only tunnel interface now. Router ID on router 1 is 1.1.1, router ID on router 2 is 2.2.2, and router ID on router 3 is 3.3.3. I have advertised this network, the tunnel the network which is running on tunnel interface on all routers. That means we don't have any problem on OSPF configuration as well. But there is one thing missing, right? As you know, OSPF send, let me show you one thing. If I will debug OSPF hello message over here, debug IP OSPF hello. So see, this router or all routers will send hello message on multicast address. So we need to map multicast address as well, then only OSPF neighborship will come up. You can see it is sending OSPF hello message on multicast address, right? All routers are sending OSPF hello message on multicast address, but here we have NBMA address that is unicast, so it should send unicast hello message, yes or no? So I need to run one more command on tunnel interface on all routers, interface tunnel 1. I'm going to add this command, IP NHRP map multicast to 11.1.1.1. This is the NBMA address of router 1. Let me run this command on router number 2 also. Exit interface tunnel. Okay, on router number 2 I have run. On router number 3, go to router 3, then interface tunnel 1, IP NHRP map multicasting to 11.1.1.1, and I have to run this same command on router number 1 also. So let me take you to R1, go to config T, then interface tunnel 1, and then IP NHRP map multicasting, and here you can use dynamic keyword as well, or you can manually provide the NBMA address 22.1.1.1 and 33.1.1.1. Now you can see OSPF neighborship is in full state. So IP OSPF neighbor, so 2.2.2 neighborship is still in access start state. Neighborship is still in access start or in exchange state. Wait for some time, it is in exchange start state. On router number 2, let me verify it. So IP OSPF neighbor, so neighbor 1.1.1 neighborship is stuck in access start state. Still we have some problem, but here now I have mapping. So run interface, we have mapping for multicasting. So run interface tunnel 1, you can see I have add this keyword here, IP NHRP map multicast 11.1.1.1, but still OSPF neighborship is till access start state. So now again we need to verify that why we have this problem. So guys, this is hub and spoke topology. As you know, this is hub and spoke topology, right? In hub and spoke topology, OSPF network type can be point to multi-point, or OSPF network type can be point to multi-point non-broadcast. These two types of network type we can configure in hub and spoke topology. And if I will talk about the full mesh topology, so in full mesh topology we can configure OSPF network type broadcast as well as non-broadcast. And if I will talk about one more type of network is there in OSPF, that is point to point. So in case of normal GRE tunnel, when you are configuring normal GRE tunnel, then your network type should be point to point. So in this scenario, network type should be either network site type can be point to multi-point, or it can be point to multi-point non-broadcast. So let me check what network type is running here, right? Because if network type is not point to multi-point or point to multi-point broadcast non-broadcast, then OSPF will not work fine in hub and spoke topology. So let me take you to router number 2, and on router number 2 I am going to check. So IP OSPF interface serial 2/0, not serial 2/0, sorry, on tunnel interface, tunnel 1 include and say type network type. So include, here we need to add include keyword. So here you can see guys, network type is point to point. This is the problem. This is problem because my topology is hub and spoke. So network type should be point to multi-point, not point to point. Point to point network type should be configured in normal GRE, right? So here I need to change OSPF network type as well. How to change OSPF network type? I will take you directly to the interface, tunnel interface. First of all, let me configure it on R1. So here is my router 1. Go to config T, then interface, tunnel 1, and then IP, OSPF, network, point to multi-point. That's it. I have configured network type point to multi-point on router number 1. Let me do same thing on router number 2 also. Interface, tunnel 1, IP, OSPF, network, point to multi-point. And on router number 3 also, I need to change network type here. Interface interface, tunnel 1, IP, OSPF, network, point to multi-point. By default, network type was point to point because you can see the link between your router and ISP is serial. So that's why on tunnel interface network type was point to point. And now you can verify OSPF neighborship. Now let me take you to router number 1. Now I am not getting the log messages as well. So IP, OSPF, neighbor. Now you can see both neighbor is up. Neighborship with 3.3.3 state is full. Neighborship with 2.2.2 state is full. Getting my point? Now we have neighborship on router number 1. On router number 2 also you can check. So IP OSPF neighbor. So IP OSPF neighbor. There is no neighborship between router 2 and router 3 because router 1 is connected with router 2 and router 1 is connected with router number 3. There is no any connectivity. There is no any tunnel between router 2 and router 3. Getting my point? On these router 2 and router 3, we have configure point to point GRE. On router number 1, I have configured point to multi-point GRE. Getting my point? So that's why here you can see neighbor 1.1.1 neighborship state is full, and there is no concept of DR and VDR. As you know, when network type is point to multi-point, then OSPF DR and VDR election not happened. And now if you will check hello timer and date timer, so hello time will be 30 seconds guys, not 10 seconds. So IP OSPF interface tunnel 1, you can see so network type is point to multi-point. This is the cost, and state is okay, this one, and hello time is you can see 30 seconds, date time is 120 seconds. On all routers you can verify hello time will be 30 seconds. Let me show you on router number 1. So IP OSPF interface tunnel 1, hello time is 30 seconds, date time is 120 seconds. Now OSPF is working fine. I am going to advertise now LAN networks in OSPF. Okay, so go to R1. So IP route OSPF. You can see I am not I have learned only these two network, right? From through OSPF we don't have 30 network and 20 network. So I am going to advertise LAN network in OSPF. Interface F0/0, I am going to say IP OSPF 1 area 0. That's it. On router number 2 also interface F0/0 IP OSPF 1 area 0, and on router number 3 also let me configure it. Interface F0/0 IP OSPF 1 area 0. Now let me verify the routing table of R3, let's say. So IP route. Now you can see inside the routing table we have 30 network and I have 10 network also. We can filter the output. So IP route OSPF, you can see I have 10 network and I have 20 network. So now let me verify the connectivity from R3 from PC number 1. Okay, I am going to ping PC2 or PC3. First of all, on R1 also, if you want to verify the routing table, so IP route OSPF, you can see I have 20 network as well as 30 network. On router number 2 also, you can see, so IP route OSPF, I have 30 network, 30.1.1.0, and next hop IP address is the IP address of hub router R1, because R1 will not modify the next hop IP address. Okay, network type is point to multi-point. Here this is behavior of point to multi-point. When R3 will advertise this network to R1, and R1 will modify the next hop IP address, and then it will share to R2. In the same way, when R2 will share this network to R1, it will install in their routing table. After that, it will update the next hop IP address, and then it will share to R3. So R3 will get 20.1.1.0 network from router number 1. Next hop IP address will be router 1 IP address. Here you can see 30 network. On router number 3, 20 network. Next hop is 192.168.10.1. Okay, now let me take you to PC1 again. Where is PC1? Here it is, and I am going to ping 20.1.1.2, and now it should work. Let me check. Now you can see ping is working. Now PC1 is able to ping PC2, and in the same way let me ping PC3 also. Ping 30.1.1.2. This ping will also work. You can see ping is working fine. Okay, now on PC number 2, from PC number 2 you can check the communication between branch offices as well. Ping and 30.1.1.2. So you can see branch offices can also communicate with each other. Just wait. You can see ping is working fine. And if you will trace route from router number 2, I am going to trace route 30.1.1.1 and say source is 20.1.1.1. So you can see communication is happening via headquarter, via hub router, and now all branches are able to communicate with each other. Guys, this was a small troubleshooting of OSPF over DMVPN. Okay, so now all branches are able to communicate with each other. That's it. That's all for today. Now last request to you, if you have learned something from this video, please hit on like button, guys. If you have not subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye.